Hi, Spring fans. Welcome to another installment of Spring Tips. I love it when a plan comes together. I think about spring all the time. One of the things that's so amazing to me about it is, first of all, it's been around for 20 plus odd years and we've never had to rewrite the core. And the other thing was it was designed by its very definition as a dependency injection framework, which promotes the kind of pluggability and integration you want with your APIs. It's a very cohesive experience, and where it really shines is when you get these different projects that work well together. And that comes into, you see the full picture of that possibility in Spring Boot, of course, where you can now pull in Spring Batch and Spring Integration, Spring Data, Spring AI, Spring Security, et cetera, et cetera, et cetera, and build interesting things. One of my favorite projects is Spring Batch. Spring Batch is meant to be a very easy way to solve the challenges of batch processing. You've probably done something that technically, if it were scaled and done correctly, would qualify as batch processing. ETL, extraction, transformation, and loading, for data migration, that kind of thing is technically what you would think about when you think about batch. Any kind of mainframe process probably lends itself to Spring Batch as well. And actually that speaks to the origins of Spring Batch as a project. It was developed in conjunction with Accenture back in 2006 because they wanted to help people move off of mainframes, right? This is a very natural way to do that, but it's useful for so much more. Anywhere you have large amounts of sequential data access, be it with text files or files of some sort, or SQL databases or message queues or anything really, then this can be a very interesting tool to have, because you want a tool that allows you to break apart large chunks of data and process them in chunks. And that's what Spring Batch does. It's got lots of mechanisms, primitives as well, for helping you work more efficiently. You can have steps that do a little bit of IO per stage, and then you can string those steps together for under one. Within those steps themselves, you can use thread executors, to do certain things at the same time within the same JVM. And to that end, it's very useful to have virtual threads enabled and upgraded. So make sure you're using Java 21 for the best results. But even there, one wonders, couldn't we make things just a bit more efficient? How could we do that? Well, what if we could divide the work across multiple nodes? And it turns out Spring Batch, because it is just another Spring project which has great support for abstractions, is ready for this. You can, without abandoning the domain that you already understand, which is a job and a bunch of steps, you can use Spring Batch's remote partition support. This allows you to send work over to any of a number of different worker nodes, have them process it, and then communicate back to the leader node that is done. Having this has the effect of reducing by the number of nodes that you've got the time it takes to finish the IO in that particular step. So if you have 5 nodes and you have 100 records, each does 20 at the same time, you've got yourself a finished step, right? In 1/5 of the time that you would have otherwise. It's a good deal. And that's what we're going to look at today, my friends. Now, this is just the beginning. We've already looked at Spring Batch well, I've looked at it a number of times actually over the years in the Spring Tip series. One of the earliest videos I did was actually on Spring Batch. And mercifully, a lot of that has not changed. So I'll refer you to that for the basics. That said, you might notice that there are some syntax differences here. I'm using the latest and greatest versions of Spring Batch and so on. And of course, some things have gotten a little bit nicer over the years. You might in particular notice that we're using builders instead of factories. Like, for example, step builder factory is just step builder now, for example. But basically, it's the same. Conceptually, it's the same. It's almost identically the same in terms of the code. It might even compile if you had the old one. I think we didn't remove those types yet, but they're certainly deprecated. Either way, enjoy. All right, let's dive right into it. We'll go to start.spring.io. We're going to build a new application. I'm going to call this leader. We're going to use Java 21, of course. We're going to use the Graalvm native image support. We're going to use Postgres. We're going to use the Spring integration support. We're going to use Spring Batch. We're going to use Docker Compose. We're going to use RabbitMQ. And I think I'm happy with that. So let's go ahead and hit generate. And we might as well generate the worker node as well, since it'll be basically identical in every way except for some of the properties there. So we'll go ahead and do that as well. Now let's open this up in our IDE. First, we'll work on the leader node. We've got the leader application. let's go ahead and get started. So remember, first things first, this is going to be an application that requires a Postgres SQL database and RabbitMQ. We selected Docker Compose on the Spring Initializer, and that gave us this. This is a YAML file for Docker Compose. I'm going to modify it ever so gently just to explicitly expose the ports on my local host machine. But bear in mind, my database, secret, and my user. Secret and my user. Okay, so we need to specify those. This is the Docker Compose file. If we leave things as configured, Spring Boot will automatically start these things up for me when the application starts up. I'm going to disable the Docker Compose support just to keep things more clear about what's happening. Okay, so let's move compose.yaml upward to here. Okay, so it's no longer in our directory here. We're going to connect to it, but of course we first need to start it up. So let's go ahead and start it. There's Postgres, and there's Rabbit. Okay, so application.properties. Name of the workload is called Spring application name is leader. Spring dot, and then the password is secret. The username is my user. And copy and paste both of these. We'll just replace this with data source. Okay, and this will be I overextended there. Okay, there we go. So there's this, and then we need the Spring data source URL. So here's that: JDBC :postgres SQL localhost low my database. All right, very good. What else do we want? Well, we want to make sure that this is, when we're doing all this I/O, we want to be as efficient as possible. So we'll use virtual threads, right? We're using Java 21. This is huge. First things first, we want some SQL to be initialized when the application runs. So schema.sql create table if not exists customer ID serial primary key name text not null. All right, there's one table, and we want another one here called customer job buckets. This will have the customer ID, which will reference the customer table ID. All right, and then we want the bucket name, bucket text not null. Okay, so what else do we need? I guess we want to tell Spring Boot to run that file. So we'll say Spring SQL init always. And you know what? While we're at it, we also have some Spring Batch SQL that we need to run. And it's the same exact parameter, the same enum. So we want always as opposed to embedded or never. And then we can go back here and we can create our sample SQL data. Okay, so we're going to say delete from customer job buckets customer. And then we're just going to insert some records into the database. Okay, so same as always. There's me. Just add some other people here who are on the Spring team. Spencer, Stefan. All right, so that's 11 rows, okay? Not a round number, not convenient, not nice at all, in fact, but keep that in mind, 11 rows. Okay, so we have the application data. I think we're all set there. Let's actually build the application, shall we? So let's see. The application is going to talk to our SQL database, and it's going to have there's going to be a Spring batch job. So I suppose we can, let's get started with the batch job just so you can see what's actually required. And you'll see that it's pretty trivial, really. Okay, job repository, turn new job repository, or job builder rather, passing in the name. So this will be called job. Sure, we're going to pass that in. Repository. We'll come back to this and we'll say step manager step. Okay, manager step build. All right, good. Incrementer. New run ID incrementer, just like normal, regular Spring Batch stuff, okay? And that's pretty much it, right? There's nothing special about that. It's just a job. We're going to create a step, though, and that is where things get a little more interesting. So it'll be called the manager step, and this is not a real step. This is a proxy step. Oh, I don't have the Spring Batch integration support, so let's go here. We'll add batch Spring Batch integration, re-import. Okay, let's create the step. This is where things get a little interesting. So step is manager step. Let's say return new remote partition manager step builder, manager step, pass in the job repository just as before. I'm gonna do a lot more than that, but we'll start with that. Okay, so we've got a few things we need to satisfy before we can even start to look at the specifics here. So job explorer. Okay, good. In factory. All right. And then we need to look at the grid size. Let's just say some magic number here. 3. All right. And then the partitioner. And so the question here is, what is the name of the step on the worker nodes that will handle the work? And we're going to call it worker step, because I am nothing if not great with names. Component, static class, Spring tips partitioner, implements partitioner. Okay, implement that. And we'll inject that here. All right, what else? Okay, so now we have to have, remember, this is not a real step. It's going to be a proxy step, a facade, a gateway. It's going to in turn orchestrate work being done on the worker nodes. And it's going to do that over a messaging substrate. And how is that messaging substrate going to be integrated into our application? Well, with Spring integration, of course. So we have to specify the output channel on which requests flow and the input channel on which replies flow. So message channel, requests. Okay, requests, replies. All right, that looks pretty good so far. We've got our manager step, we've got our job, and that's basically it, right? There might be something else. Let's see. And that's basically it. So now we have a job and a single step. Now, obviously, jobs can have one or more steps, and each step can have I/O. But this is just one step, and it's not even a real step in the sense that we've normally come to expect it to be. It's a proxy. And so now this is going to require us to define some channels so that it can connect to our messaging substrate. And we also need to define the glue code using Spring Innovation. But before we do that, let's return to our humble partitioner here. This, my friends, is where all the magic happens. This partitioner's job is to take a grid size, specified here, and produce a map containing a unique partition ID and the data to be sent to that partition to clue it in on what it's supposed to do, e.g., read this much data from this thing or whatever. Now, this context is not tied to anything. It's just a map full of keys and values that you can send to any partition. What you do with it there is up to you. You can use a tasklet and use information in the context to send an email, or you can read ranged chunks of data from a SQL database or a flat file or whatever, using the information specified in this context. It's a very generic, open-ended mechanism. It's just a way of dividing up the work. So let's actually take advantage of it, okay? So var contexts equals new hash map. Okay, there's that. And we're going to, for var I is 0, I is less than grid size, I plus plus, we're going to context.put. We have to put a partition name. Okay, partition name equals partition I plus 1. Okay, and partition name. And then we put in a new execution context, which in turn takes a map, which in turn will have a, these are the attributes we want to send to the downstream worker. Right, so it's just a map that we're sending. Okay, so pretty straightforward. It's a map, it's a context map that in turn contains keys and the execution context, which in turn is basically just a map. So it's a map of maps. All right, and so our job is to return that map of maps, and each map specified here as a context will get sent to the partition. Now, the real question then is, what do these numbers mean, right? How is this supposed to inform what we're supposed to do? Well, what we want to do is, in essence, give the thing that's on the worker node a roadmap, some guidance on what work to do. And if it was just a simple sequential number range, 1, 2, 3, 4, 5, all the way up to a bazillion trillion, we could do something pretty sensible and say, okay, maybe you should start with rows 0 to 100, and then you start from rows 100 to 200 and 200 to 300, or 100 to 200,000 or 200,000 to a million, whatever the size that you're comfortable with each node doing, you would have specified that here. But in our case, we have porous IDs, right? We have IDs that don't conform to a series. They're a sequence, and Postgres reserves the right to not pack those numbers back in. So we might get very lumpy sort of distributions of numbers. So that didn't work. And so what I wanted was some way to bucket all of the IDs so that they automatically get associated to a partition. And there's actually a great way to do that with Postgres in particular. There's a function on the server called ntile. So let's go ahead and do that. So var SQL, another of millions of great uses for multi-line strings. Thank you so much. So we want to say insert into customer job buckets the ID and the bucket. Select customer ID, select ID from select ID, comma, partition, concatenation. I'm going to specify tile over order by ID as bucket from customer. Okay, so it's going to select two columns. This is going to select records from the customer table. So let's go ahead and see what this does. Okay, I'm going to go ahead and log into our SQL database here. We'll ask IntelliJ to create a connection for us. Thank you. And go here, paste that in. So remember, this is the grid size. So if the grid size is 5, then what do we get? Well, we get this, right? So these are the IDs of customers, and these are the random, generated buckets, the partitions. Okay. Well, what if the grid size is 3, right? Okay. Well, so you can see that all the data, all 11 records, has been fairly, distributed across all those different partitions. So there's 4, and then 3, right? Because it tried to do 4 per partition, but of course there's only 3 left. 3, in the modulus, there's only 3 left. So it did a good job. It actually did a really good job, and it doesn't care about what the ID is, and it's just, I think it's a very simple thing. So we're going to run that query again, and we're going to use it to fill this table, customer job buckets, right? And the customer job buckets table looks like this. So bucket ID and customer ID. Okay, so we need to specify customer ID. So that looks like it'll work. Let's go ahead and run it. So DB, we need a SQL database here. And then we'll say this.db.SQL, update that. We need to specify a parameter, params, that'll be the grid size, of course. Okay, so that's this right here, end tile, parenthesis, that is the grid size. Okay, so we're going to run that before we allocate the partitions. So now, when we do this, we'll have a table that has a mapping of IDs to partition. And we're saying for all the worker nodes, you're going to get a partition name, just like we saw in the SQL table. The records were 1, 2, 3, not 0, 1. So we added 1 here to create the partition name. And we're doing the same kind of math here. We're going through the grid size, and we're creating partitions. And that'll be just fine, because then each partition will get a key, an attribute that's sent to it that gives it the partition name. It'll then look for all the customers to process that are assigned to that partition name. Okay, pretty straightforward, I hope. Okay, good. So we've got the partitioner, we've got the manager step, we've got the repository, we've got all the Spring Batch stuff. But what about Spring integration? How do we connect all of this stuff to the worker nodes? Well, that involves some basic glue code here. So I'm going to create a message channel for requests, like so. Direct, okay. And replies. And now we need some basic glue code that tells us, given a request on a channel, these channels are named queues, basically. They're logically just queues. So we're going to say when a message is put on that channel as a request, what do I do with it, right? Well, that glue code is described here with this handy DSL. So I'm going to inject the message channel requests. And by the way, this is just this ultimately gets turned into this, and I can inject it by its ID. So requests and replies. Okay, so when a request comes in that channel, that pipe, basically, I want to handle it by sending it to the outbound channel adapter for Spring integration for AMQP, which is, of course, the protocol spoken by RabbitMQ. So there's this, and the routing key in this case is requests. Okay, very good. Now, what about the replies? The ones after we've sent the work over to the worker node, and then once it's finished, it'll send back a reply. And I want to capture that as well. So I'll say return integration flow dot from replies dot get, and we're gonna take the data from RabbitMQ actually. Okay, so now we're gonna say return integration flow dot from AMQP inbound adapter. We're listening for requests coming in on the replies queue in RabbitMQ, okay? And then we'll send it to the replies channel and get the results, okay? Now, there's one more thing I want to do, and that's because we're sending data over the wire, and it's going to be serialized. So I'm going to configure the simple message converter to allow serialization no matter what the module is, the Java module. Okay, there's that. That's for Jackson and other things that might care. Okay, so I've got my replies flow. I've got my inbound flow. I'm saying when a message arrives on RabbitMQ, send it into the replies channel. Conversely, when somebody puts a message in the request channel, send it out to RabbitMQ. Okay, so two different flows, but they're symmetrical. And then we want to make sure, down here we got requests, replies. we're plugging those in. So the requests go out and request, the incoming replies come on the replies channel. I think we're almost ready to run. Let's just make sure that we don't have Docker Compose here anymore. Don't need that. And here we go. All right, looks like it's up and running. It seems to have done something. Yeah, launched the job with the following parameters, but obviously no response because we don't have any worker nodes, right? So let's take care of that now. Let's go back to the command line. UAO worker.zip worker application. There's going to be a lot of common things to the worker and the leader. So let's just copy some of the configuration here. Okay, I'll copy all that into the application, the worker application, and we're going to keep the name here, worker. We also don't want Docker Compose support here. Get rid of that. We also want to add Spring Batch integration. Command-Shift-I. And okay, I think we're ready to actually start doing the work again. So same kind of thing here. We're going to set up a bit of Spring Batch machinery to receive the requests and do the actual work, delegating to our actual steps. We'll have the step. So we're going to call this the worker step. All right, and we're going to use the job repository, new remote worker step builder, worker step, okay? And we'll have the job explorer as well. And we'll chunk it, let's say 3 records at a time. That's an obviously nonsensically small number, but I've only got, for less than 4 times that much data. So we need a nice, easy to understand division. And we're going to specify a chunk. And this is going to be just like standard Spring Batch, if you've seen it before. We're going to have our types there as well. So public record customer, string name. We'll say customer. And then reader, writer. Okay. So for the writer, I'll just do this in line here. We'll just say chunk for each system out print line. Okay. So you can see the contract there. I've got an accumulation of 3 rows at a time, right? And now obviously this would be a markedly larger number in a real application. But again, we're just trying to keep it so that we can kind of follow what's going on. But I do need a reader here. I still haven't specified that. So let's specify an item reader for data of type customer. Okay. We also need our input channels to be specified and our output channel. Okay, so we'll, same as before, just in reverse, requests, replies. Okay, and the input channel is requests, and the output channel are the replies. Okay, now you see, you could specify a tasklet, just like in regular Spring Batch. Okay, easy. That's great if you want to do like something that doesn't require specific I/O support, right? But we're going to use the I/O support. It's kind of the most interesting example here. Tasklets are just an escape hatch. You can run arbitrary code in whatever structure you want. What else do we need to specify? Well, a partitioner. And this partitioner requires the worker step name, okay, and an implementation of partitioner. So what does that look like? Well, okay, so we've got this, and I think we've got almost everything that we need for that step. We need a bean factory, that's for sure. Okay. All right, good. There's our step. Now what else do we need? Well, we need the actual thing that does the item reading, right? Don't we? So let's make this step scoped. That's a Spring Batch speak for the idea that this bean will get recreated every time you run a batch job. So item reader for data of type customer, JDBC item reader. Okay. Return new JDBC paging item reader builder customer. Data source, pass in the data source, build, sort keys, map of. We're going to sort via the ID, order ascending. We want to we want to specify a select clause. So select all from clause from customer, right? And then we want a where clause. So where ID in, okay. And then we specify select b.customer ID from customer job buckets, B, where B.partition, where B.bucket equals partition. And of course, the parameter is partition. That's going to be coming from the execution context, which contains that data that I was showing you about earlier. So at value, step execution context, partition, string partition. All right, okay, parameter values. And map.of partition. Okay, so now we have the injected partition, we have the select query, select all from customer, where the ID is in this sub select. Select b.customer ID from customer job buckets b, where b.bucket equals partition. Okay, and then we have the parameter. So we're going to parameterize that SQL query with this partition variable. So that's what that is. We need to specify the row mapper, telling it how to map data from the SQL database into a customer. Easy. We got our nice Java API here. Works really nicely with lambdas. Okay, easy, good. And we also want to specify page size. Let's just say 10, for example. And I guess we should provide a name as well. So I'll call this item JDBC item reader. Okay, there's our item reader, and there's our step. That's all the Spring Batch machinery, but just as last time, we need to have some integration code for our channels. So let's go over here to our leader, and we'll just copy and paste that code, and we can just flip it around. Here are the channels, okay? And here are the integration flows. Now, the code is backwards now. So we're going to move the names around, okay? So the request flow says, when a request comes in on the requests destination in RabbitMQ, I want to read it in and then send it on the requests channel. Okay. Over here, we're saying when a request comes in from the replies channel, we want to send it via RabbitMQ to the replies destination. All right. And that's the replies flow dealing with replies. That's the requests flow dealing with requests. Easy. Got this. All right. So I think we're ready. If we see we're injecting requests and replies, the requests are coming in as a worker on the request channel, and they're leaving out on the replies channel. I think we're ready to actually just go ahead and run this. Let's try it. Neat. There you go. So we have 3 records, 4 records, and 4 records. So it's clearly worked. It's divided the work up. But of course, this is just one node. Let's run multiple nodes here. I'm going to modify the options. I'll say allow multiple instances. Hit apply. Hit OK. And then I'll restart this. There's one instance. I'm going to start yet another. That'll be the second one running. And a third one. Okay, so now I'm going to return to my leader node and restart the thing. Have it create some more data, some more work for the nodes. So we can see over here, we got 3 records in one of the worker nodes, 4 records in the other worker node, and 4 other records still in the other worker node. So it's divided the work up. So now that work, instead of arriving sequentially like it did when we had only one node, is, there's work stealing going on. It's the aggressive consumer pattern, right? It's load balancing by being a greedy consumer from the queue. This is exactly what we want. We get free horizontal scale now, all because we're using smart technologies that are designed to do this kind of stuff. And obviously, I showed this example to you in terms of just regular SQL, but there's nothing specific about it, nothing magic here. I'm in the leader node, we are sending a partition, and that partition is being used on the worker node to figure out, sort of where to, how to divide the work. And then that's the rest of it. We just have to give Spring Batch a clue about how to do that, and it does the rest of it for us. All we had to do is now process the code in the worker, just like we would anything else. This is all basic, Spring Batch stuff. The only thing that's a little interesting here is the input channel and the output channel and this factory method. Okay, now this is a really, really efficient application. It's dividing the work across multiple nodes. Thankfully, we're also, on the same node, insofar as we're doing I/O, we're also getting the most efficient use of threads thanks to that. I want to turn this into a GraalVM native image. And I confess, friends, I did bump into a few subtle issues, and I've already filed an issue. I'm sure that'll get fixed soon enough. But in the meantime, I have to add the following GraalVM AOT hints using the Spring AOT component model. On the worker, I have to register these hints. What this is saying is I want to register the step execution request handler for reflection of all types, and I want to register the step execution request itself for serialization. Pretty straightforward, I think. Okay, we had to do that. Most of it works just fine. We just had to do these 2 types for the worker nodes. For the leader nodes, I had to register support for the message channel partition handler for reflection and the step execution request for serialization. Okay, let's go ahead and compile everything into GraalVM native image and see how this works in that context. So, as always, I'll just do Gradle native compile for the worker. Okay, the worker has compiled. Let me go ahead and compile the leader node now. All right, let's go ahead and start the leader. Okay, it's up and running. Now let's go start a few instances of the worker, right? I think the first one finished all the work, and so the others didn't get a chance to participate in that. Clearly, it's working. Let's see if it divides again. So we're going to restart the leader, and here you can see we got more data, more data, more data. Nice. So now we have an application that uses virtual threads. It starts up in like a tenth of a second, 100 milliseconds or so. And of course, if we look at the memory of all these wonderful things, about 100 megabytes, right? Oh, RSS. Look at that, 100. So divide by 1,000, right? So 107 megs. This is a really good result. We got concurrency both within the JVM thanks to non-blocking I/O. We've got easy concurrency across nodes. I created a very simple, albeit workable partitioner, but you could do the same thing, right? You could create even more sophisticated a partitioner. And for example, let's say that you realize in this code that you're going to need 10 partitions. Right before you actually return here, you could use the Kubernetes Java API to spin up 10 different containers that have the worker node in it, right? And that way they'll be ready and able to process the work when the work suddenly gets transmitted over the message queue. And then as soon as they're done, guess what? They can shut themselves down using the Kubernetes Java API, which, by the way, also works with Ground. Now you've got Spring Batch doing what it does best. You've got Spring Integration doing what it does best. You've got Java working really well together here as well. You've got solid middleware like RabbitMQ or Kafka. Think about the other places where you have lots of data. AI right now is a huge place where people are dealing with lots of data and they want to get it into for example, a vector store. Bring in Spring AI, wrap the abstraction in an item writer, and then just write your data that you're ingesting to a vector store. And there are probably half dozen supported by Spring AI already. And you've got yourself, the beginnings of a really nice retrieval augmented generation pipeline, or RAG. This is a good place to be. And of course, we've only begun to scratch the surface. In this episode, we looked at remote partitioning. In another episode, one day, we're going to look at remote chunking. The difference being that in this case, we have a leader that is communicating the extents of the data that it wants to process to the workers, as opposed to the data itself. So the worker nodes in this case are able to read the data by reaching into the same SQL database as the leader node. But if we wanted the worker nodes to be sort of oblivious to the original I/O, to the original source of the data, then we would have to send the data itself over the messaging substrate. Different strategies and different use cases and different strengths and weaknesses. I figured we start with this one because this one's pretty common, pretty useful, especially if you have lots of data. You don't want to be sending all of your, terabytes of data across your message broker, even though, for example, with Kafka or something like that, you definitely could.